Good afternoon. My name's Ken Takemura. I'm a member of the Technology and Performance Architects team here at InterSystems. This session is on automated InterSystems IRIS cloud scaling. So just a brief overview. I'm going to talk about some concepts and terminology, and then also toward the end we'll talk about how you can utilize InterSystems IRIS and auto scaling. So this is actually a fairly basic and introductory level type of session. So if you're already familiar with working in the cloud and working with auto scaling, this might be a bit redundant. So anyway, let's move on. Okay, so first we actually are going to do a demonstration. Anton Umnikov, who's our senior cloud solution architect, is going to demonstrate the InterSystems IRIS performance test drive, which provides an actual test of high performance data ingestion. So it's just, it's not necessarily tied to auto scaling, but it's an example of the scalability of InterSystems IRIS. So go ahead, Anton.
Thank you, Ken. Okay, sounds good. So what I'm going to show you is we worked hard and we worked a lot on provisioning IRIS in the cloud in different ways. Tomorrow you would see what we internally call a t-shirt sizes deployment, where you literally select what kind of IRIS you want to deploy, what kind of data volumes, data performance you want it to handle. Another project we're working on is how do you see the performance of the IRIS? And to do that, not only we have to deploy IRIS, in this case, in clustered fashion, we have to deploy multiple drivers that would push performance into the system and do some sort of benchmark. If you see, if you've seen the Dmitri's presentation on Monday, he was talking about his typical workload where you have orders and fields and you have to ingest them into the database as fast as possible. Harry here worked on the performance benchmark that would do exactly that, that would generate these fake orders and fields, but they look realistic. So on Dmitri's slide, it's just a couple of dozens of characters. In reality, they close to 1 kilobyte each record. So what we're going to do right now, we'll feed this generated data into a cluster of 12 IRIS instances and see how many records per second we can ingest into this cluster. So what I'm doing right now is I'm starting the 4 driver nodes. Each node would generate 64 client threads that would be pushing data into IRIS. And let's see how far we can get it. So right away, we're going about 1 million records per second. Right, as you can see, we're going up to 1,500,000, close to 1 gigabyte of data ingested per second into the cluster of 12 IRIS nodes. Right, so one of our bosses say, hey, we were asking like, okay, we can do 70, 80,000 records per second on the laptop where driver and the IRIS on the same laptop. How much do you want us to show in the cloud? They pick number out of the air, 1 million. Here's 1 million. Right, sustained load average 1 million records per second on 12 node IRIS cluster. I can give you all the specs and so on. What do we do next? We push to 10 millions, or we trying to figure out what's the least expensive configuration in the cloud that can sustain 1 million? Or we trying some other kinds of benchmarks. We don't know at this point, right? What in this for you other than impressive number and bragging rights for us, right? As a side effect, you get this. You can deploy similar configuration. Yeah, even AWS console failed. So let's try it again. You can deploy similar configuration with driver, with multi-node cluster, and run your own benchmark, and it takes just a few minutes to provision. So let's go to CloudFormation. right? We wouldn't deploy such a big cluster. We deploy just a cluster of single driver and four nodes. Let's create stack, upload the template for shards, open. Next, I need to name my cluster, Anton 32. The driver node, type of the IRIS cluster node, and the key I would use to. So, cluster node in this particular case, the IRIS working in sharded configuration, and shard consists of 12 shard nodes. What I'm provisioning right now is the similar cluster with 4 nodes, right? This demo with 1 million is driven by 4 driver nodes. I'm doing just 1 driver node in this case, right? It takes, okay, I haven't hit the final create stack button, right? And we see some resources being provisioned. We start with a security group, then we provision the first node of the cluster, then we provision all the other nodes that have been connected to them, and in less than 5 minutes, you'll be able to run the same benchmark on a smaller scale. Right? Right after this session at the Tech Exchange, I'll be doing similar presentation, but I'll have more time and I'll be able to get into all the details of what exactly we're doing there. There's very interesting business going on in terms of what volumes we provision underneath, because there are specific requirements for journal, for write image journal volumes on AWS and so on, right? But if we'll wait for few more minutes, I would not hold Ken with his presentation, but we'll have IRIS cluster with 4 nodes ready to run exactly the same benchmark as we did. We just wouldn't get to 1 million records per second. Thank you.
Thank you, Anton. Okay, so most of you have heard of the cloud, but the cloud can come in different forms. When cloud is mentioned, we often think most about the public clouds. Public clouds are provided by third-party providers over the public internet. So the most common providers are, of course, Amazon Web Services, or AWS, Microsoft Azure, and Google Cloud. And InterSystems currently has partnerships with all of these. Oops. Okay, another type of cloud is a private cloud. In this illustration, which might be something you have in your data centers today, you have like a set of racks with physical servers configured with some type of virtualization software like VMware's vSphere. You have storage and maybe an expansion rack. So basically, you've got your own private cloud where you can use this as a pool of resources, and you can allocate and create virtual machines to meet your needs. Some enterprises will choose private cloud over public cloud for reasons of privacy, security, and control. Okay. And one of the things that private cloud can provide over the traditional bare metal type of infrastructure is improved agility over deployment. So in the past, it might take weeks or months even to deploy a physical bare metal server. Virtualized VMs or virtualized machines, virtual machines can be potentially provisioned in minutes. There's also something called a hybrid cloud, which is a blend of public and private clouds. You might choose to run applications in public cloud, some in private cloud, and there could be reasons based on load, availability, or other things as well. You may even choose to migrate applications between public and private depending on what your needs are. A lot of enterprises, I think, start out by with the public cloud by migrating things like non-production loads like development and test systems. Once they get some experience and familiarity and comfort with that, then they consider moving live production environments to the cloud, public cloud. Sometimes also with production systems, you might have a production system that's in your on-premise data center, but you might want to deploy a disaster recovery system out in the public cloud as well. So it gives you an option to have an off-site disaster recovery without having to stand up your own secondary data center. So with hybrid cloud, there's also a couple of interesting developments in the last few years, where the management of both private and public clouds, in order to maintain sort of a consistent appearance and management, there are now products that allow you to do that. AWS Outpost is one product where they actually now sell their hardware that they use in their own data centers, and you can place it on your premises, and you can manage it using the AWS tools and complete infrastructure. So it's a consistent experience across both private and public. Same thing with VMware on AWS, where you can choose to deploy VMware's products and tools and manage that across both public and private clouds. Anybody using either of those today? Just curious. Anton. Okay, good. All right. Some of you may have heard of the pets and cattle analogy to comparing traditional infrastructure to cloud transformation. So with traditional on-premise resources, they're kind of like pets. You treat them as indispensable and unique. They're manually built, managed, and hand-fed. And when you lose one, it's a catastrophic event. So you think about, your main production system that's on-premise. You often build it very manually, configure it, and it's often very difficult to replace if something ever happens to it. So with resources that can be created near identically, like web servers and app servers, these are more like cattle. These are like commodity type of devices and commodity type of applications. So sometimes they're deployed in large numbers. They're often managed by automation and repeatable processes. And when you lose one, it's not a big deal. You can simply replace it easily without any significant disruption. Okay, so what is scalability? Scalability is the ability to support increasing workloads through the addition of resources such as CPU, memory, and storage. It's also the S in InterSystems IRIS. So as you know, that IRIS is an acronym. InterSystems products have always had a strong focus on high performance and scalability, or massive scalability. And Anton's demonstration is kind of an example of that. We constantly work with our partners to test new technology, including hardware, develop new code to support even higher user counts and workloads. One of the primary, objectives or tenets of what we do with new releases is that each new release is actually must be faster than the previous release. So when we release something new, it should be faster than the last one. Okay, and then scalability is important. It's not only about adding resources, but it's about using them efficiently and effectively. Okay, so with regard to scalability, there's a couple ways you can go. One is called vertical scalability, or scaling up. This means that for applications that are running on a single monolithic server, you can increase its capacity by adding resources like CPU, memory, and storage. You can start out with a very large system if you think you might need that growth, or you can buy but you have to buy a pretty big server at a very premium price. If you use the cattle analogy, this is like getting a bigger cow to give you more milk. So it's the same way. If you have an application you need to grow, you add more resources to the server, make the server bigger. So, however, in using that type of growth, there are limits to vertical scalability, particularly with technology and cost. Generally, cost is not linear. So as you add additional resources, you have higher costs per unit. You quickly get to a point of diminishing returns. Larger cow costs more, has higher maintenance cost, doesn't provide linear returns. In other words, if you get a cow that's twice as large, you might not get twice as much milk from it. There could be other complications as well. So with higher-end servers, you probably are all aware that some of the high-end servers with very large core counts have very premium prices. They're expensive to maintain. And with many applications, they won't scale linearly. So in other words, as you utilize more and more of the cores, you get a diminishing returns on that increase. And so basically, you're paying more for the added potential capacity, but not able to utilize it fully. So InterSystems IRIS scales well vertically on many high-end servers. We also have features to support vertical scalability, including parallel SQL query execution, which distributes SQL work across cores. And we have the work queue manager, which distributes object script work across cores. The advantages of scaling up or vertical scaling is that it's generally pretty simple and straightforward, but the disadvantages primarily cost and running into limits in the scaling. Okay, with horizontal scaling or scaling up, InterSystems IRIS scales well. I'm sorry, last slide. There we go. Horizontal scalability, instead of getting bigger resources, this means adding more resources, like adding more cattle or more servers. This leverages commodity, virtual, and cloud-based resources. And with horizontal scalability, you can achieve near linear price performance and your limitations are much higher. Okay, and then with horizontal scalability, this is actually key to what we call elasticity, which we'll get to in a moment. So with InterSystems IRIS, you have horizontal scaling capability. So with our Enterprise Cache Protocol, or ECP, you can scale more users across more application servers. And for distribution of data, sharding can be used to partition the data volume. So queries against the data are decomposed into multiple subqueries, run in parallel, and then the results are combined and returned to the user. Both of these are transparent to the user, and they're independent of each other, but can be used together. Okay, what is elasticity? Elasticity is not the same as scalability. So elasticity is the ability of a system to provision and deprovision resources in an automatic manner, matching your current workload demands. So an example of elasticity is with how Amazon handles their Prime Day. As you know, Prime Day is a big event. There are a lot of specials and a lot more customer traffic. And so they can handle these loads, hopefully without crashing their systems. And for Prime Day 2019, AWS actually scaled up to 426,000 server equivalents at its peak. And that's 426,000 server equivalents. That's pretty mind-boggling. Okay, so what are the characteristics of elasticity? On demand, so elastic cloud resources are scaled to match demand. If you have peak user loads, you might have Elastic Cloud Resources provide you with the resources you need to support the load. Maybe it might be mid-morning or mid-afternoon if you're in a clinic situation. Another example might be end-of-month processing, or in some with financial systems, possibly you might have like midnight processing as well. When you have an on-premise deployment, you have to size systems to meet the largest anticipated load and add a margin for safety. Sizing isn't exact, you can be wrong. And so to deploy a system on-premise, you have to do the sizing, you have to do speccing out, you have to get approval for the purchase, make the order, get the order in, and then you have to deploy the hardware. A lot of work, and it can take weeks to months to do that. Cost saving. So if you have an elastic system, you basically pay only for the resources you need. So it's right sizing at all times. You don't need to over-provision or overspend. In the past, cloud was almost always more expensive than on-premise solution, but nowadays we're finding that's changed. So we've done some internal cost studies recently that show pretty significant savings by going to the cloud. Resiliency, you can automatically detect poor health of a resource, shut it down, and start up a replacement. And kind of like what we said in the last slide, elasticity requires horizontal scalability. Okay, what are scalability sets? Scalability sets allow you to create and manage identical load balanced instances. So that way, the number of instances increases and decreases in response to rules, whether it be a schedule or some type of demand monitoring. Scalability sets can also provide high availability by detecting the health of an instance and automatically replacing it if needed. You can build very large-scale services. And distribute across multiple data centers or a single data center. With most scalability sets, there's the ability to automatically integrate it with a load balancer and configure those as you scale up and down. So again, this is reducing your costs by efficiently using the resources and right time, right sizing. So all of the major public cloud providers have some type of feature to support scalability sets. So AWS has EC2 auto scaling. Azure has something they refer to as auto scaling, and GCP just simply calls it auto scaling. So here's a comparison of a traditional sizing versus auto scaling. So assume that you have an application that you can scale horizontally. The load on the application varies by the day of the week as shown. With traditional sizing, like for on-premise, you buy a machine that can support the highest peak load, and usually you add a little safety margin on top of that. So in this example, basically, we've sized a machine that will handle the peak load on Wednesday and no more. The problem with this is that you have a lot of capacity that is not used when it's not peak time. So you really are paying for that unused capacity. We see in a lot of cases that, and it's not uncommon to see systems that are idle 95% of the time, so very low utilization. Okay, an alternative to that type of sizing is to size for average load. You don't have as much wasted capacity, but at peak times, you may not have enough resources. So this leads to poor performance and bad user experience. So something like this, though, is almost never acceptable. Okay, so with auto scaling, you can adjust the capacity as needed automatically. Adjustments, like I mentioned, can occur on a schedule or dynamically respond to monitoring the load. So basically, your capacity goes up and down as needed, and so you're only paying for the capacity that you actually have configured at any particular time. Okay, so with InterSystems IRIS and Scalability sets, you have here sort of a typical three-tiered application, web servers, application server, a pair of data servers in a mirror. And with scalability sets, what you can do is you can horizontally scale both the web servers and application servers to meet your demand load. So both of these can be scaled automatically, with no intervention. Is anybody doing anything like that today? Just curious. Okay, there's a few. Anybody have thoughts or plans about doing that with their production operations? No. Okay. Want to add to, I know we're talking a lot about containers here. So containers, this is not unique to containers, but they can be used but not required. You can also use ICM to instantiate the InterSystems IRIS instances. Okay, one thing I wanted to mention here too is that I think they made some of the announcements here, but there is a new cloud license model. So it's an hourly model, and it's available only on the cloud marketplaces for AWS and Azure. I have some shortened links up there if you want to actually take a look. But the software cost is based on the instance type. The instance type meaning how many cores and memory and things like that you're configuring it on. But it starts as low as just 63 cents per hour. Okay, and then with that, I think that's pretty much it. Does anybody have any questions?
So do we have any cost analysis when we use the traditional one and we are moving to cloud based on need?
We don't have any cost analysis that we've done yet, but I think that'll be coming soon.
So for example, our company is using the traditional way. We have our own data centers. So when we want to propose cloud, we can give numbers. Okay, this is what we are saving.
Yeah.
Yes, definitely there is a benefit. So when we have high availability needed, we can auto scale and increase capacity.
Yeah.
That is definitely true. But in terms of money, so how much my annual cost will needed to invest in this? So that will be very helpful.
Yeah, yeah. Is your application one that you can horizontally scale with like ECP and web servers? So auto scaling doesn't really apply to vertical scaling. But
today it's vertical.
Oh, today it's vertical. Okay. But the potential exists to do horizontal scaling. Okay, and if you can get to that, then you have the potential to be able to implement auto scaling. Thank you. Okay, guess not. Just want to add, the presentation also has links to the other sessions here at Global Summit related to cloud. Thank you all very much.